Hello everyone, welcome to MBA Karo. My name is Pranav Pant and I'm a multiple time 99.9 plus percentiler in CAT, and I'm going to bring up this video series for 30 days named Hot Summer, High Order Thinking Summer. So this series is going to help you build concepts for CAT 2024. So if you are a CAT 2024 aspirant or no CAT 2024 aspirants, please do share this video with all of them. This is the first class of this series. I will show you the schedule for the entire month of June. Every day, I'll be taking up a class on a different topic, and we will be covering some good quality questions that will help you build concepts of different topics for CAT. And it will cover all the three sections. So, if you are new to the channel, please do subscribe to the channel and follow us on social media platforms. Now, the first thing that we are going to do today is number system, and in number system also we will cover certain things like divisibility, last digit, okay, etc. These things will be covered in today's video. So please do subscribe to the channel and don't forget to follow us on Instagram, Telegram, etc. So this is the schedule. So in case you wish to know that on what day you will be getting which class. So for entire 30 days of June, we shall be having a class. Today we are going to start with number system. Tomorrow we'll have a class on arrangement, then another class on number system, then parajumbles, and so on. So it covers all the three sections. Out of 30, we have 13 classes on quant, 10 on DILR, and 7 on VARC. So please do watch all these videos, and I'm pretty sure if you watch all these classes, that will definitely boost your preparation for CAT and other MBA entrance examinations. So, in case you are looking for a structured preparation, we have batches for CAT, and if you wish to enroll in our CAT second batch, you can get 20% off. You need to use the code HOT, and it is valid till 30th of June. So, if you are watching this video and you find the content useful and wish to prepare in a structured manner from us, you can enroll in our batch. It has live classes which are available in recorded formats later on till the course validity. You get topic wise practice sheets. There is a doubt resolution group for enrolled students. You will also be getting full length and sectional mock test and GDBI preparation with us. Okay, and the course validity is till 31st of March. So, in case you appear on other examinations like NMAT, SNAP, ZAT, etc., you still have that content available with you and you can prepare using those classes. So, if you use this code, you get 20% off. So, you can get this as 20K. So now we are going to start this class. The rule is simple, right? If you want to get the maximum benefit, pause the video at every question, try to solve the question and then look at the solution. Okay, in case you are unable to solve it or are not aware of the concept, then you can directly view the solutions. So this is the right way to practice, and if you just look at the solutions, that is not going to help you. So first give it your own try and then look at the solution. So let's begin with the first question. It says that a number is of this format 0 point ABC, 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 and so on, where A, B, and C are non-zero digits. By which of the following numbers should n be multiplied to get an integer product? Now, this is a simple question which probably many people already know the answer of. But if you do not know the answer, let us understand that n is given by 0 point ABC, 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 where these are the digits. Suppose if I take 10n, that will become A point BC, ABC, ABC, and so on. Okay, but if you take the difference, you will not get a you will get a non-zero decimal, post decimal part, right? So if you take a difference, this will not be zero. Now, how to bring the part ABC after the decimal? So, if I multiply by 10, I get A point BC. If I multiply by 100, I get AB dot CABC. If I multiply by 1000, and if I multiply by 1000, I will get ABC dot ABC, 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 and so on. So, if I take 1000n, that is ABC point ABC, 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 and so on, right? And N was 0 point ABC, 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 and so on. The digits keep on going. So if we subtract, we get 999N is equal to, this part is common, okay, which will be removed after subtraction. So 999 is ABC. Now n should be multiplied. If I multiply n by 999, we will get an integer product because ABC are integers. So the answer is 999. Here's the next question. Four consecutive prime numbers are arranged in ascending order. The product of the first three numbers is 20,677 and that of the last three numbers is 33263. Find the sum of the first and the last number. Now this appears to be a difficult question because like 2677 and 33,263, you'll have to think of the prime factorization. How can you factorize them? And these are pretty big numbers. Okay, so let us understand how to solve it by hit and trial to get the right answer. This has to be done by hit and trial, but not a blind hit and trial. It has to be a logical, you have to arrive at the solution logically. So if you look at the prime numbers, okay, so just looking at the prime numbers 2, 3, 5, 7, 11, 13, and so on. The prime numbers are close by. Like if you take three prime numbers, they are close by, isn't it? It's not that, and these won't be very large prime numbers. These will be simply two-digit numbers, right? You do not have a difference of, let us say, 10 or 12 between two prime numbers. Either difference is either like 4 or 2, right? Difference is usually 2 or 4 or maybe more, but usually between these ranges 2, 4, or 6, not more than that. Okay, now if you think of three numbers, let us say the numbers are at a difference of n. Let's say the numbers are n minus 2, n and n plus 2. So this is the thought process. If you look at, if you multiply three numbers, we are assuming that the difference is 2. We are not assuming that a very big difference. So this becomes n into n square minus 1, minus 4. So that results somewhere in n cube minus 4n, right? So what I mean to say is this is close to n cube, roughly n cube, right? So even if you take n plus 4, like you will get some value close to n cube. So basically what I mean to say is you need to think of the cube root. This is the thought process that you need to develop to get an estimate number. Okay, and then we will use some other techniques to figure out the exact number. So suppose 2677, right? You know 20 cube is, uh, if you look 30 cube is 27,000. Okay, so we need to think of the central number less than 30, because if you take 30 cube is 27,000, and you do not need to know the cube of 28, 27, 29, anything else. Just think of this, the center number should be less than 30. So we will do a hit and trial. The central number is less than 30, right? So if I take the central number 29, what is the prime number less than 29? 23. And the next prime number is 31. Okay, I've taken these numbers. Now if you have to find the product, one way is to find the product. CAT gives you that liberty to use a calculator, but we will do it without taking a calculator and estimating the answers. Okay, so 3 into 9 is 7, and 7 into 1, the last digit is 7. So the number ends in 7. So this is justified. Like this is justified. This could be the numbers. Okay, so this is not sure. Now the last three. So there are four numbers. So first three are these. Next three are 29, 31, and 37. Okay, so again let's do the estimate. 9 into 1 is 9. 9 into 7 is 3. So last digit is 3. Okay, and this is the central number must be greater than 30. Greater than 30 cube. Central number is more than 30. So this is a very rough estimate that we can use to get the numbers. Now, one thing is you can divide any of the numbers and check for yourself. Like for example, you can divide the first number by 23 and check if it is divisible by 23. And or you can do it as 37. Second number you can divide by 37 to get uh, the surety that these numbers are divisible by this. But that is not needed. Okay, this is our hit and trial method, and that would work. So we have 23, 29, 31, and 37. These are the four prime numbers. You can actually do the calculations using a calculator and see the answer. Now 23 plus 37, the sum is 60. So if this is a question that you get in the examination, you are going to solve it this way rather than like using a calculator. This is the logic that you need to build upon, that the product should be close to the cube of the central number. Okay, so we know that the cube is less than 30. So if you try further smaller prime numbers, so if you take the prime numbers like 19, 23, and 29. So if we take the lower numbers, 9 into 3 is 7, 7 into 9 is 3. Okay, and it is ending in 7, which is not matching. Okay, so this a perfect hit and trial that will give us the answer. Next question says that there are 60 children, they are standing in a circle. Child 1 has a ring. The ring is passed clockwise in the following manner. Child 1 passes this on to child 2. Child 2 passes on to child 4. Child 4 passes to 7. 7 passes to 11, and so on. After how many such transfers will the ring be in the hands of child 1 again? So this is a very good question. See, 1 passes to 2. Okay, 2 passes to 4, 4 passes to 7, 7 passes to 11. So next will be 16, then you will add 6, that is 22. But how come you find out that when will child 1 receive the ring again? Now this has to do something with the sum of first and natural numbers. N plus 1 by 2. Okay, that is the sum of first and natural numbers. So if you see that sums are 1, 3, 6, 10, okay, 15, 21, and so on. But in this we are getting the numbers as 1, 2. Okay, so 2, 4, 7, like 1 more than this. Is it clear? So we are getting 1 more than these numbers, right? So we need to find a number in this series which is of this format: n plus 1 by 2 plus 1. Okay. Now there are 60 children. Now if you see 61 is another thing that you need to see is it should be divisible by 60 plus 1. So it should be equal to some 60k plus 1. Okay, because you need to get back to the first child. So first 61, then 121, right, and so on. So you need to think of this: n plus 1 by 2 should be a multiple of 60k, right? It should be a multiple of 60. So if you put 14, 14 into 15 by 2 gets 105, which is not a multiple of 60. If you take 15, 15 into 16 by 2, that is 120, right? It is a multiple of 60. Now let us be careful that after 15 transfers will it be back to 1. Okay, so after one transfer it is at 2. Okay, this is one transfer. After two transfers it is at 4. After three transfers at 7. After four transfers at 10. After five transfers at 16, right? After six transfers, so after 15 transfers it will be at, after 15 transfers it will be at 121, which is again the first child. Okay, so the answer is going to be 15 for this question. So after 15 transfers, it will be at 121, which is a multiple of 60 plus 1. So child 1 will get it again. A number a factorial ends in 28 zeros, while a number b factorial ends in 31 zeros. Where a and b are natural numbers, what is the maximum possible difference between a and b? Okay, so how do you find the number of zeros in a factorial is you keep dividing by 5. So let's say if you have to find, let's say 60 factorial. Okay, so just taking an example, you divide by 5, you get 12. 12 divide by 5, you get 2. Now it is no more divisible, so you get 14 zeros. Okay, and let's take another number. Let's take a higher number, that is 260. So 260 divided by 5, you get 65. 65 divided by 5, 13. 13 divided by 5 is 2. So we have 80 as the result. Okay. So what we notice is that we can find from the number of from the factorial we can find the number of zeros, right? Now from the number of zeros, how to determine the factorial? That's a big challenge for us. Okay, so what we need to think of is, think of a number. Sorry, this is not 65, this is 53. 52, made a mistake here. 52 by 5 is 10 and 10 by 5 is 2, so this is 64. Okay, that was a mistake. So 52 and 10 and 2, that is 64. Now, if you have to find, we know that factorial, we can find the number of zeros, but we need to think in a reverse way. So remember this rule that it is approximately 4 times. Approximately 4 times. And approximately 4 times. Not exactly 4 times, but approximately 4 times. So what we will do, 28 zeros, 28 into 4 is 112. Okay. So let us check with 112, right? So let's check how much do we get at 112. 112 divided by 5 is 22. 22 divided by 5 is 4. Okay. So we get, and 4 we cannot divide further. So we get 26 zeros, right? So this is not exactly 112, right? This is slightly more than 4 times. Okay, slightly greater than 4 times. So if you take 115, this has 26 zeros. 115 factorial will give another 0. It will make it 27 zeros. 120 factorial will make 28 zeros. Okay. So when you take 120 factorial, you get 28 zeros. Now when you take 125 factorial, in 125 factorial you get 5 cube. Okay, that means 3 zeros get added here. It becomes 31. So at 120 factorial you will get 120 factorial, we have uh, 28 zeros, and 125 factorial we have 31 zeros. Now see this, 126 factorial will not make any impact, right? It will still have 31 zeros. 127 will also have 31. 128, 129 factorial, all will have 31 zeros. As soon as we bring 130 factorial, so it has an element of 5, so that results in 32 zeros. Okay, so this means that we need to go till 129 factorial. Now let's look at the question. It says that A ends in 128 zero, A ends in 28 zeros and B ends in this. We need to find the maximum possible difference between A and B. So B is the larger number. So we will take the largest possible value of B and the smallest possible value of A. So smallest possible value of A is 120. That gives us 28 zeros. Okay. And largest possible value of B is 129. So the difference is of 9. So that's how we answer this question. So this was about the number of trailing zeros in factorials. Alright, so let's move ahead to the next question. It says that if A, B, C and D, E, F are both 3-digit numbers, such that A, B, C, D, E, F are distinct and non-zero digits, such that A, B, C plus D, E, F is equal to 1, 1, 1, 1. Okay. Then what is the value of A, B, C, D, E, F? Now this question is about adding two numbers like A, B, C, D, E, F, and these are different digits. Okay. Now, how do we add it is these are different digits, and so if we add C plus F, right, and these are non-zero digits, so we cannot have 0 and 1 giving us 1 here. So it must definitely be C plus F should be 11. Okay, C plus F is 11, fine. So it will give us 1 carry. Now B plus E cannot be 0. So B plus E should be 10. So that 10 plus 1 becomes 11. And then A plus D should also be 10. Okay, so A plus D is 10. So this C plus F is 11. That gives 1 carry. B plus E is 10. 1 carry is 11. And again 10 plus 1 carry 11. So we get 1, 1, 1, 1. So we need to find the sum of A, B, C, D, E, F. So we get the sum as adding these three, we get 31 as the sum. Now the problem with this question is some students would think that what would be the values of A, B, C, D, E, F. You do not have to find those values individually. It does not say that find the values individually. So let us take some example. Like let's say if I take 3, 8, okay, then I cannot take 3 and 8. So I'll take 4 and 6, okay, and then 1 and 9. That is a possible solution. Similarly, I can take 9, 2, 3, 7, and 4, 6. Right. So, like these are, there will be many more solutions. Now, it will become a different question of permutation combination if I ask how many such solutions exist. Right. So, if you are interested in permutation combination, please answer that question that how many numbers are such that there are distinct digits and you get this sum. Okay. So, the answer to this question is 31. You get the sum of A, B, C, D, E, F. I hope you are enjoying this session. Please don't forget to like this video and share it with fellow CAT aspirants so that they also get benefited from the same. Let's move on to the next question. Find the last digit of 1 to the power 1, 2 to the power 2, 3 to the power 3, and so on up to 2024 is to the power 2024. So this question is about the last digit and using the cyclicity of powers, we can find the last digit. So we will find 1 to the power 1. See, the last digit depends on the last digit here and the power mod 4. So if power is n to the power p depends on like the last digit n and p mod 4. Okay. So 1 to the power 1, 2 to the power 2, 3 to the power 3, 4 to the power 4, 5 to the power 1, 6 to the power 2, 7 to the power 3, okay, 8 to the power 4, 9 to the power, then again 1, okay, then 10 to the power 2, then 11 to the power 3, because when I take 11 to the power 11, that means 11, or again that would be that 1 to the power 3. Okay, then 12 to the power 12 would mean we'll take 2 as the digit and fourth power. 13 to the power 13 would mean that we will take 3 as the digit, and when you divide by 4 you get 1 as the result. Okay. Then 14 to the power 14 would mean that we need 4 as the digit and the power should be 2 because the cyclicity is 4, okay, for all powers. Now this will be 5 to the power 3, 6 to the power 4, 7 to the power 1. So 17 raised to the power 17 will mean you need 7 as the last digit, and When you divide by 4, you get 1 as the 8 to the power 2, 9 to the power 3, and 10 to the power 4. Okay, or 0 as the last digit. And then again, it will become, when you take 21 to the power 21, it becomes 1 to the power 1. So this cyclicity will repeat. So we will find the last digits in this case and then attempt it. But this is a difficult, time consuming question, better to be avoided during the examination. So let us fill in the values. 2 to the power 2 is 4, 3 to the power 3 is 27, 7. This is 6, 5, 6 carry power is 6, 7, 9, 3. Okay, 8 to the fourth power is 8, 8 is 6, and 8, 8 is 4, then 2 and 6. Okay, 9 key odd power is 9, this is 0, this is 0, this is 9 into the power 2 is 4, 7 to the power 1 is 7, 6 carry power is 6, this is 5, this is 6, this is 3, this is 6, and this is 1. Okay, so let's just add this. This is 12, 18, 23, 29, 32, 32 plus 15, 47. Okay, and this is 7, 10, 16, 21, 27, 34, 47. So we get 94. 94 from 20. Okay. Now we need to go till 2024. So basically 20 into 100 is 2000 into 101 plus 4 more numbers. Okay. So basically the last digit is, till here is 4. Okay. Till 20, the last digit is 4. Last digit is 4. So 4 into 101. And then we will check for these four numbers. Like 2021, if you use 2021 raised to the power 1, that will end in 1. Okay, or 2021 to the power 2021, that will end in 1. Okay, so these will repeat. 2022 to the power 2022 will basically mean 2 raised to the power 2, and that will end in 4, 7, and 6. So this was thus far 94, that is 4 was the last digit for 20 numbers, and this cyclicity is 101 times. So 4 into 101, that is 4 is the last digit thus far, and add all these, that will be 5, 9, 9 plus 9 plus 13 is 22. So the last digit turns out to be 2. Okay, so a difficult question to get, and this is the answer. In an examination, it is advisable to skip such a question. Okay, next question is on last two digits. You need to find the last two digits of this number. Find the last two digits of 1 factorial plus 2 factorial and so on. Now understand that 1 factorial is 1, 2 factorial is 2, 6, 24, 5 factorial is 120, 6 factorial is 720, 7 factorial is 5040. Now we are concerned with the last two digits, right? So we will just ignore the other digits. This is 1, 2, 3 factorial, 4 factorial, 5 factorial, 6 factorial, 7 factorial, 8 factorial. If you multiply, that will be something ending in 20, right? Like if you find 5040 into 8 is 40,320. We are concerned with the last two digits, right? Just last multiply the last two digits by the next number. So you get 80. 10 factorial will end in double zeros. Okay, so we do not need numbers beyond this because they will all end in double zeros. 11 factorial will have two zeros, 12 factorial, and so on. So we need to count till 9 factorial. Okay, it does not mean anything beyond that. Okay, so just add this. This is 30, 33. Okay, 33, and then we have 20, 20, 40, and 100. Okay, 60 plus 40, 100. 100 plus 80 is 180. 180 plus 33, 230. So last two digits are 30. So that is the answer to this question. Find the number of trailing zeros at the end of 50 factorial divided by 10 factorial. So this we already discussed how to find the number of trailing zeros at the end of a product. Okay. So 50 factorial will have 50 divided by 5 is 10. 10 divided by 5 is 2. Right. So it has 12 zeros. Now 10 factorial has 2 zeros. Okay, so when we divide a number ending in 12 zeros, let us take 9 into and then 12 zeros, 10 raised to the power 12, and let's say uh, whatever be that number, okay, and since this number is always divisible, right, it has uh, like two zeros. So whatever be the number, let us say x, y. Okay, that will be an integer because the numbers will be divisible. So 50 factorial has higher numbers. Numbers will be divisible, like whatever be the numbers. Okay, so x followed by 12 zeros and x will be divisible by y for sure. Because if you take any number, if you take 9, right, it will contain 9 also. There will be many multiples of 9. If it will contain 8, many multiples of 8. It will contain 7 multiples of 7. Okay, so that will cancel out. So this will be an integer. No need to worry about it. Okay, that will be integer for sure. So 10 and subtract 2, that is 10 zeros. So the number of zeros at the end of this product is, this division is 10. Next question is on divisibility by 11. So this says that number 4925x86y4 is divisible by 11. What is the least value that x minus y can assume? Okay, so let's say the divisibility by 11 says that you would write alternate digits 4925. This is x, 8, 6, y, and 4, 8, 9 digits, right? So take this sum and this sum. So 6, 6, 10, 16, x plus 16. And this is 14, 22, y plus 22. Okay. So now the thing is, the difference is either 0 or a multiple of 11. Okay. So if it is 0, so either x plus 16 is equal to y plus 22. So you get uh, x minus y is 6. That is one of the options. But there is also a possibility that x plus 16 is y plus 22, and this could also mean that the difference is 11. So basically y plus 22 is equal to x plus 16 plus 11. Okay. So there can be a difference of 11 also between these two quantities. So the difference is either 0 or a multiple of 11. So if we take by this logic, then we get x minus y. If you bring y this side and take this side, it becomes minus 5. Now, if you think of 22, what will happen? So in this case, if you take 22 here, then it will be x minus y is equal to 38 minus 16. But these are single digit numbers, right? X and y are digits, so they cannot have a difference of 16. So that is not possible. So the minimum possible difference, least value will be minus 5. Okay, so that is our answer. The number of positive integers n in the range n is between 2 and 50 such that n minus 1 factorial is not divisible by n is. So you'll have to apply a bit of thinking in this question and determine what category of numbers would n mean. So n minus 1 factorial should not be divisible by n. Okay, and n should start from, it basically is 3 to 49. Okay, n minus 2 factorial. So if you put n is equal to 3, Okay, so n minus 1 factorial is 2 factorial is 2. 4 if you take, then it is 6. 5 if you take, 24. 6, 7, 8, and so on. Now 5 factorial is 120. Okay, 7, the 6 factorial is 720. 8, it is 5040. We will not be calculating the remaining values, just to note one pattern, right? So we need to find, it should be not divisible by n. It is not divisible by n, so we accept it. It is not divisible by n, we will accept it. Not divisible by n, we will accept it. It is divisible. Okay, it is not divisible, it is divisible. Now n minus 1 factorial is not divisible by n, right? Now which numbers reduce the divisibilities? Which numbers will reduce the divisibilities? So if you give it a bit of thought, okay, if you see, the prime numbers reduce the divisibility. So if you have 6 factorial and divided by 7, it will not be divisible, right? If you take 10 factorial divided by 11, it will not be divisible, because we have not yet had an element of 11, isn't it? 11 आया नहीं, जब तक 11 फैक्टोरियल नहीं आएगा तब तक 11 नहीं आएगा, जब तक 13 फैक्टोरियल नहीं आएगा 13 नहीं आएगा. So this means one set of the numbers is prime numbers. प्राइम नंबर्स में डेफिनेटली नहीं होगा. नॉन प्राइम्स में सोचते हैं till what it happens. See, 4 is non-prime, okay, and 6 is not divisible. But when we look at 6, right, 5 factorial तक, see 6 के क्या क्या factors हैं, 2 और 3. 5 factorial तक दोनों आ चुके हैं. 8, if you look, the prime factorials are 2 and 4, right? 7 factorial तक दोनों आ चुके हैं. 10, if you look, 2 and 5 are the prime factors, right? So they are already arrived till 9 factorial. So on, if you see, if you take 12 or any non-prime number, let's say if you take 9 factorial, right? 9 factorial is basically 3 into 3. Till 8 factorial you get 3 and 6, so both are present. Okay, so if you take any, if you take odd also, let's say 15 factorial. Okay, so if you take till 14 factorial, 3 has arrived, 5 has arrived, okay, 6 has arrived, 10 has arrived, so 15 is already present there. Okay, so this means that it will have prime numbers and 4 as the another number, right? So we'll have to count prime numbers from between 2 and 50. Okay, so we have to count these prime numbers. So what are the prime numbers? 2 will not count because it should be greater than 2. So 3, 4, then we have 5 as the prime number, 7, 11, 13, 17, 19, 23, 29, 31, 37. Then we have 41, 43, and 47. Just do a recount. 5, 7, 11, 13, 15 is not a prime, 17, 19, 21 is not a prime, 25, 27 not primes, then straight away 37, 41, 43, 47. So count these numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 such numbers. So it was a good difficult question and required a lot of thought that as to which numbers should one count in this category. I hope you are enjoying these questions thus far. So please don't forget to like this video and please watch this series completely. That will help you build concepts across different topics. I've already shared the schedule for 30 days, okay, which is going to have some solid sessions on different topics that will cover all the concepts and all the chapters across all the sections. So please do watch this series completely. What is the highest power of 20 that can divide 1000 factorial? Okay, so we need to find a highest power of 20 in 1000 factorial. Now see this, 20 can be broken into 2 square and 5. So we will find the power of 2 square, we will find the power of 5. Whatever is the lower value, we will accept that. Okay. So if you look at 1000 factorial में 5 की power, okay, so that is 200. Then we have 200 divided by 5 is 40. 40 divided by 5 is 8. 8 divided by 5 is so 249. 5 की power है 240. 4 की power we cannot directly check. So we will check 2 की power. So 1000 by 2 is 500. Then by 2 is 250. Then by 2 is 125. Then you will get 62, 31, 15. Okay, and then 7, 3, 1. Add this 750, 875, 93, 100, 975. Okay, 975 plus 19, 994. Okay, 2 की power is 994. That means 4 की power or 2 square की power 497. 994 yeah, right? 758 75, and this will give us 497. Okay, so we know that we will have to choose the lower of the two. So the answer is 249, because although the power of 4 is 497, but we need to consider that 5 should also have that power, because we are altogether dividing by 20 and 5 has just a power of 249. Next question. A student writes a two-digit number, reverses its digits, and adds it to the original number. He gets the result as x. Which of the following cannot be the sum of digits of x? So this is about the digits in a two-digit number. Okay, so when we look at two-digit number, let us say the number is 10 a plus b. The reverse is 10b plus a. When we add, so we get 11 times a plus 11 times b. So 11 times of a plus b. Okay. He gets the result as x. So that is the result, which is x. Okay. now, now, so it is basically a multiple of 11, right? So a plus b is a and b are the digits. So it is a multiple of 11. What are the multiples of 11? 11, 22, 33, 44, 55, and so on. Okay. Now it says the sum of digits of x. So sum of digits will be 2, 4. Although x is not 11. X won't be possible as 11. We will have to take minimum 1 and 2. So basically it will start from 33. Okay, minimum. This is the minimum values of a and b that we can think of. So sum of digits is 6, 8, 10. These are the values of x. Okay, so we can x can go until 8 and 9 also. Okay, so total can be 17 into 11 can be 187 also. Right, we will get a higher value also, but we will focus on these and check the options. Now 6, 8, 10, 12, these are all possible. 9 is not possible as the sum of digits. Okay, so if you take a higher number, let's say 110, the sum of digits is 2. Take 121, the digits is 4. Okay, 132, if you take the sum of digits is 6. So the sum of digits is always an even number, so it cannot be 9. So that is why 9 is the answer to this question. Next question. The number 37 raised to the power 75 and 47 raised to the power 75 is not divisible by which of these numbers? Okay, so this is a question on divisibility rules. So if a number is given, right? So if we are given this thing that some odd number, okay, odd number की power x plus odd number, another odd number की power x, so that is divisible by, like, or instead we can say that a to the power x plus b to the power x is divisible by a plus b if x is odd. Okay, so basically this number is divisible by 37 plus 47 is 84. Right, so 84, it is divisible by 84. Now, if you look at this, 2 is a factor of 84, so it will be divisible by 2. It will be divisible by 3. It will be divisible by 7. It should not be divisible by, we will have to check whether it is divisible by 5 or not. Okay, so if you see 7 raised to the power 37 raised to the power 75, 7 raised to the power 75 means uh, 7 raised to the power 3. Okay, and this is also 7 raised to the power 3 which ends in 3, and this also ends in 3. The last digit is 6, which is not divisible by 5. So it is not divisible by 5, it is divisible by all others. Why? Because this number is divisible by sum of a and b, which is 84. So if it is divisible by 84, it will automatically be divisible by its factors. So 2, 3 and 7 divide that number, but not 5. A number 1 plus 11 to the power 39 is divisible by x. Which of the following numbers is also divisible by x? So just now we saw this property also, that if a number is divisible by a number, so if we take odd powers of it, right? So if let's say x plus 1, or instead of x, let us call it y plus 1. Okay. So this is basically 11 to the power 39. We have treated as y. So if we take odd powers of y, if n is odd, so if you take odd multiples of, if you take odd powers of y, that number is divisible. Okay, so that is this property. Okay, so if you have odd powers, it is divisible by y plus 1. So we are treating y as this. So if we have any number, any odd multiple of 39, 11 raised to the power odd multiple of 39, that will be divisible by 11 to the power 39 plus 1. So this number is less than it, so it will not be divisible. 11 to the power 78, this is even power, and this is also even power. This is the odd power of it. Okay, so 11 by 39, if we treat it like, basically if you take that y plus y as this, so this number is basically y cube plus 1. Okay, so y cube plus 1 is divisible by y plus 1. Okay, it is divisible if this power is odd. Okay, so this is the property that will be used here. So this is a number which will have x as a factor. This not necessary will have x as the factor. If we were given the other way around, अगर हमें ये दिया होता 11 की power 13 plus 1 has a factor x, then this is true, divisible by, तब ये true होता. But if this is given, it is not necessary that this other way around will be true. Okay, so the answer is 1 plus 11 की power 117. If n is the largest multiple of 55, that can be found by using all the digits 0, 1, 2, 3, 4, 5 and 6 just once. Find the sum of the last 3 digits of n. So basically you'll have to find the last 3 digits of this number. It's quite hot these days, and instead of stepping out, if you build your thinking skills using this video series, that is going to definitely help you. The temperature has crossed 50 plus in North India, and severe heat, so I've thought of bringing this series for you. Largest multiple of 55 using these digits, right? Now when we have to make the largest number, we try to put the digits, we have to put 1, 2, 3, we have to put 7 digits here, right? 1, 2, 3, 4, 5, 6, 7. 7 digits. We will put the large digit here and smaller digit here, right? Now if you see this, we will try to put the largest digit here and the smallest digit here. But that does not mean that this is our answer, because it should be a multiple of 55, right? Now, if it is a multiple of 55, that means it's a multiple of 11 and 5. 5 का concept क्या होता है? Last digit should be 0 or 5. And 11 का concept is alternate digit sum. Now, this is a very good question, and like let's find that what could be the sum of these digits, right? So, if you take all these digits 0 to 6, the sum is 21. Okay. Now, the alternate digit sum, I told you in one of the previous questions also, either let's say the sum is A and B, either A is equal to B or the difference is 11, 22, etc. Okay. So now we cannot have the sum equal because the total is 21. We cannot have two equal sums such that their total is 21, right? So we will have this thing 11. Okay. So a plus b, if you take 21 and a minus b is 11, so we get 16 and 5. So we need to make sum of 16 and 5. So we will have to select digits, right? We will have to make 4 digits that their sum is 16 and try to make 5 as the sum. So basically what we get is, now this is a very good question and a very high order thinking question. In fact, they should add up to 5, and these numbers will add up to 16. Okay. Now, if we have to take large numbers like 16 हमें लेना है, तो बड़े बड़े digit लेने होंगे. 5 हमें 3 numbers में बनाना है, so we'll have to take small digits, right? Now think, can we take 0 here? So it is said that either you take 0 or 5 as the last digit. So if we take 0, we will have to make 16 using these three numbers. Okay. And if we take the maximum 3, we get 4, 5 and 6, which is only 15. So we cannot take 0 here. So one thing is sure, that the last digit is 5. So one digit is 5 in this. Now we need to think of 3 digits that make up to 11. And we will have to make up 3 digits that have to make 5. Okay. So if you have to make the largest possible number, right, we have to give the largest digit here. So 5 is already taken. We have to make a total of 16 using these 4 numbers. So why not take 6? Let's try to take the highest possible number here, 6. So why did we take 6? Because we have to make the largest number. So we will take 6. Now 11 is done. We need to make 5 more, right? So let us try to take a large digit here. Try to take large to large digits here. So 5 is remaining. Can we make 4 and 1? So we can make 4 and 1 like this. Why did we take 4 here? Because we have to make a largest number. So हमें यहाँ पे large digit लेना है and the number digits should decrease. Now here it was a compulsion to take 5. So that is why we took 5 at the last digit. Okay. Now we have to take these 3 digits and we need to take digits in decreasing order. So we are left with 3 more digits, which is 3, 2 and 0. So we will try to take 3 here and 2 here and 0 here. So this is how we will get the largest possible number, which is a multiple of, or we will think alternatively, right? We will not do this thing. Let's just think, I made a mistake here in fact. Think this way. This we need to get a large digit, right? See, largest नहीं आना चाहिए, उसके बाद आना चाहिए. We cannot put 5 here. Can we put 4 here? Because this will be in fact a larger number. Because see, largest digit is same, then second largest will matter. So instead of that 4 we took there, so we should take 4, 1 and 0 like this in order to make this number large as possible. So 4, 1, 0 is done. Then we will have 3 and 2. So we will put basically 3 here and 2 here. That will be in fact the largest number. Okay, so if we start with the largest digit, 6 is permissible. 5 we cannot place here, so we have to place 5 here because of the constraint that it is a multiple of 5. So it's a multiple of 5, last digit could be 0 or 5. If we were putting 0, we were not getting this sum as 16. Okay, so we had to choose 5. So 5 यहाँ आ गया. अब 4 करके देखते हैं. Yes, it is possible. Now if you put 4, the sum is only 5, so 1 and 0 have to come this way, and then the remaining digits 3 and 2 in descending order. So that will be the sum. So it says that the sum of the last three digits, so last three digits are 205, the sum is 7. So it was a very difficult question involving a lot of thought process in this question. Okay, so in case you are preparing for CAT 2024 and are looking for a structured preparation, we have a batch running from it. Okay, and you can use this code HOT to get 20% off on this course. It will include live classes, recorded sessions, and doubt resolution, and full length plus sectional mock test. So this was today's session. I hope you enjoyed the session. So please don't forget to like this video and watch this series completely. That will help you build very good conceptual understanding about CAT, and will develop your ability across all the sections. So this was the first video. Please do let me know in the comments that how did you like this video, and I've already shared the schedule. And if you want PDF of this, you can get the PDF of on our Telegram channel. The link is given in the description of this video. Okay, so join our Telegram channel, and there you will get the PDF of this PPT and of the subsequent sessions as well. So that's all for this session. I hope you enjoyed solving questions from it, and do let me know in the comments that how many questions were you able to solve. हर वीडियो में आप अपना स्कोर बताना कि आपने कितने सही किए, तो उससे आप इवेलुएट कर सकते हो आपको कितना आता है और क्या आपने नया सीखा. Definitely you will learn something new in different videos, and by the end of this series you would have gained a lot of knowledge and would have become quite good at all the sections to tackle CAT 2024. So keep watching this series and don't forget to like this video.